Welcome, this is Almere reporting live for Primeur Magazine from the studio in Almere. Today I'm talking to Venkatesh Kannan from the Irish Supercomputing Center, and we will discuss things that are happening there and the developments in the context of the European supercomputing things. So, welcome Venkatesh.
Thank you very much, Ed. It's a pleasure to be here.
Yeah, can you tell a little bit about yourself as a start?
Absolutely, yeah. So as you said, my name is Venkatesh Kannan. I work as the technical manager at the Irish Centre for High-End Computing. That's what ICHEC is. And as you mentioned, we are the National Centre for High Performance Computing in Ireland. So the core mission of ICHEC is to deliver HPC-related capabilities and expertise to higher education institutions, enterprises, and public sector on behalf of the state in Ireland.
Mm-hmm. And can you tell a little bit about the size of the center? How many people are working there? What is the size of the systems, etc.?
Absolutely. So we are 40 plus, growing to 45 to 50 computational scientists at the center. We are spread across two offices, one in Dublin and the other one in Galway. The National University of Ireland in Galway is our legal host. The center itself is directly funded by two Irish government departments, one related to employment and innovation, and the other one with respect to education and skills, and hence the primary mandate to support both academia, public sector, and industries in Ireland.
Mm-hmm. Thank you. You recently had several announcements related to European projects and European centers. Can you tell a little bit about those?
Yes, absolutely. So one of the key activities that has recently been very prominent in the European HPC landscape, as you might have seen, is the EuroHPC program. So as a part of that, we recently kickstarted the National Competence Center under EuroHPC, the EuroCC activities. And the EuroCC activities within ICHEC brings the expertise in HPC and associated areas to the academic enterprise organizations in the field. So these are particularly important because these are the essential driving forces for digital transformation of the scientific industry and public administration organizations in Ireland and also within Europe. So at the moment, we particularly have the EuroCC, the National Competence Center, focusing on two specific areas. One, to support the academic and research communities. So that is done through the academic flagship program that ICHEC has already kickstarted. The objective of the academic flagship program is actually to increase the competitiveness of Irish academic groups when they are applying for access to larger European systems. So this is done by providing actually hands-on performance engineering assistance for the researchers to pretty much scale up and optimize their application codes. And by the end of the 2-year academic flagship program, we expect these research groups and their codes to be ready so that they can be successfully run in an optimized way on European Tier 0 praise systems or the pre-exascale and exascale systems that are coming up. So the scientific domains of these projects span different domains, from astronomy to artificial intelligence for nanoscience, optimization of machine learning and deep learning and material sciences.
And is also industry involved?
Yes, absolutely. So that is one aspect. The academic flagship is one aspect of the National Competence Center. The other key aspect or pillar within the Competence Center is the SME Accelerator. And this kind of ties into ICHEC's ongoing activities in bringing HPC and capabilities to enterprises. So the ICHEC in the SME Accelerator particularly works at the convergence of big data, artificial intelligence, and HPC technologies with Irish SMEs and startups and public sector organizations, pretty much to accelerate their technology adoption for digitally transforming their services and solutions. So the model of engagement is primarily towards two aspects. One, raising the technical awareness of the enterprises and public sector organizations on to what HPC and related technologies can bring to them. And second thing is to accelerate and ease their adoption and use these solutions to build their solutions pretty much.
The projects that you are doing is the EuroCC project.
Yes.
I think it kicked off a few days ago, didn't it? Do you have a special role in that, or are you just one of the competence centers?
So we are one of the participants in the EuroCC project. So we are one of the 33 national computing centers.
Other European projects that you are involved in?
Yes. So, in addition to the National Competence Center, I might actually bring your attention to a project that is focusing on the next generation of data management and storage platforms, which are going to be key to sit alongside the exascale systems that are going to come up. So, this project was recently successful. It's due to kickstart in Q1 in 2020. It's called IOC. It's a 3-year project led by a consortium. It's a 3-year project led by CEA in France. And the objective of the IOC project is to provide novel data management and storage platforms for exascale computing, platforms targeting really zettabyte scale storage systems. These are particularly 1,000 times exabyte systems. So the focus is actually to develop critical aspects of intelligent placement of extreme volumes of data across different categories and types of storage and memory components that go into these exascale systems. So this is particularly important because it's important to place the right resources and right fragments of data at different parts of the memory and storage systems so that the computation is optimized both from a performance, cost, and energy perspective at these extreme scale systems.
So that is all classical computing, let's say.
Yes.
I mean, exascale, it's of course very innovative, but it's kind of classical computing. Are you also doing things like quantum or neuromorphic computing?
Yes, particularly quantum computing, yes. So as you rightly said, quantum computing is still an essential part of high-performance computing in a general sense. Only thing it's in a different paradigm based on quantum mechanical systems. So in that respect, the focus of ICHEC is pretty much how we address high-performance computing in a classical sense. It is to understand the capabilities of the quantum computing platform and build the expertise and innovation in how we can develop applications on these quantum computing platforms. So to this end, what ICHEC have been running since 2018 at a national level is the National Quantum Programming Ireland initiative. And the primary focus of this initiative is particularly 3 strands. One is understanding how quantum computing platforms are going to be deployed alongside classical HPC systems, because at least for the foreseeable future, quantum computing platforms are seen as accelerators that will be coupled to classical HPC systems. So it is important to understand how these classical and quantum systems will be integrated at hardware, system, software, and application workflow levels. So that's one pillar of the Quantum Programming Ireland initiative. The second pillar is the R&D that we collaboratively do with a number of partners, both in academic research and industry, to understand how software and applications would be developing on these quantum computing platforms. So we have in-house expertise in developing algorithms and applications for different demonstrators and use cases on these hybrid quantum and classical HPC systems. The third particular thing is focusing on a national roadmap for developing skills, both within industry and academia, to be able to leverage quantum computing platforms alongside classic HPC systems.
Do you already have systems in place or simulators? How do you run those applications?
So by the end of the year, we would have a national quantum learning platform, which will be a quantum simulation system that will be coupled to the national supercomputer K. And that will be available for access to both academic researchers as well as industry to build their hybrid application workflows, and also for skill development particularly. So this platform will be operational by the end of the year. It's also interesting to note the pilot quantum simulator call from EuroHPC earlier this year. And we have a proposal under consideration with a number of European partners. And the focus of this proposal, soon to be announced, is to deploy quantum simulator platforms that will be tightly integrated with Primeur HPC systems. And the objective is to integrate the systems, develop the software for hybrid classical HPC applications. And if successful, ICHEC would be leading with other partners the development of the demonstrators, use cases, and also the software, the system software that allows coupling these systems.
What kind of applications are you looking for?
So we look at applications on both sides, meaning for scientific purposes and also with industrial relevance. As we know, quantum computers are far from production level scale, but in terms of scientific applications, we are looking at physics-based simulations, chemistry simulations, and on the application side, we are looking at optimization problems and chemistry problems that have an industry relevance.
And then the question I always need to ask in this, when will the first quantum computer, the real quantum computer, be there with real applications?
That's the $1 million question, probably, or even more.
That's why I asked.
It's a good sign. For example, currently within Europe, the capabilities of quantum platforms are around the order of 100 qubits. Soon towards the end of the year or early next year. For example, companies like Pascal have these analog and digital devices which can operate at 100 or 200 qubit levels. So what we see is an accelerated capability of these quantum computing platforms. So the projection to reach 1,000 order qubit system is around 2025, and that's reflected in Horizon Europe program as well. What we need to be conscious of, though, is to have these practical scale systems, we need usually 100,000 or even orders of millions of qubits. So possibly it's going to be the next decade when quantum computing might be more practical. And hence we need to prepare actually the applications and the algorithms that will be running on these kind of systems. And that's why you see a lot of projects, including NISC, which is the more recently announced quantum flagship project, of which ICHEC is also a partner. NISC is a 4-year project that is coordinated by Atos in France, and ICHEC leads the work packages and the tasks on AI and graph algorithmics. So the NISC project itself focuses on 3 strands of use cases, 10 in number. The categories of the use cases are in chemistry, in optimization, and in artificial intelligence. Particularly, ICHEC's focus is on two applications there. One is to develop a quantum-enabled natural language processing application and a use case with an industry partner. And the other application that we're looking at is for chemistry, because we're looking at how we can systematically break down larger molecules for their simulation on the smaller scale devices that we have at the moment.
Are there also other architectures that you're looking at? I mean, this is a kind of hybrid architecture with a classical supercomputing and quantum, but are you also looking at other types?
Well, we have in our horizon neuromorphic computing, and we recently have been in discussions with various partners in Ireland, such as the Dublin Institute of Advanced Sciences, to be able to address those platforms. But particularly, we are focusing on classical and quantum computing platforms for the next three-year timeline.
Okay, that all sounds very interesting. So I'm looking forward to this first quantum computing results.
Right, absolutely. So it's an exciting time.
Okay, thank you very much for this interview.
Well, thank you very much, Ed. It was a pleasure talking to you.
For Primeur Magazine, this was Almere reporting.